So continuing along in the definition of our setup, we've defined the machine, we've defined the machining coordinate system. We need to come down here and define things related to the geometry and the fixturing and so on. Before we do that, there's this third button here, and this button allows you to select the product or part that you're going to be machining. Now, if you recall, if you have a part open or a product open when you jump into the process, the prismatic machining workbench, CATIA assumes that that particular part or product is the one that you want to work with. And as you can see here, this name here corresponds to the name that's shown here. But however, there's the case if you do a cold start where you don't have a product, you have an empty, this would be empty. So this is how you would get to defining a product if you do a cold start or for a second setup, because if you recall, the second setup does not have a part associated or product associated with it. So just clicking on this button here would open the file selection dialog window, and you can navigate to whatever product it is that you want to machine during that setup, which would include fixtures and so on. So we don't have to do that in this case because it's already defined. Let's move ahead to these last set of buttons down here. Notice that there are these tabs moving over here to the right, and right now the geometry tab is the one that's selected. Even though we already have the product in the process tree, PPR tree, we still have to tell CATIA which of the parts in the product is actually the design and which is the stock, because CATIA does not know that by default. So to define the design, we click on this button here, and then what we want to do is select the design. You can either do that from the tree. So in this case, you'd have to go down to the part body level. So I'd have to come down here to this level. Or you can pick it from the graphics window. In this case, the design is hidden behind the stock, so you might have trouble grabbing it. If you do, you'd have to hold down the Alt key when you click to get this list of elements behind the pick. And if you go to the third one on the list, it will highlight the design. So let's click on that. And then you have to double click in the background. Even though you've picked it here, to get back to the input window, you'd have to double click on the background. And you can tell that you've picked what you've picked by looking at what's in this text field here. It tells me that I've picked the part body belonging to prismatic 1, which if you come into the tree here, look at prismatic 1, you can see that yes, that's true. That is the design geometry. In the same way, you can select the stock. So let's go ahead and click on, and this one is easier because the stock is in front of the part. We just click on the stock, double click in the background window, and again we can confirm that it's the right body by looking at what's in the text field here. Now for fixturing, since we went to all the trouble to define the Kurt vise, it's also helpful at times to indicate where the fixtures are, so that you can avoid them when you generate your operations. So in this case, if you look at the fixture is actually an assembly. So it's this Kurt 8-inch vise, and there are actually a number of parts that belong to this. Now I think for the purposes of collision detection, the only things that are really probably important to us would probably be these two, the moving jaw and the fixed jaw. This is highly unlikely that you would hopefully not program an operation to get into the base of the vise. And in this case, the parallels are pretty hidden. So again, it'd be very difficult for you to get into these. But if you wanted to include them, you could. So what we're going to do is click on the button next to fixture, and we're going to select the fixture of the vise, the moving jaw. I'm going to just throw the parallels in, just so that I have an indication of where the part is located in the Z direction. And as I said, you could throw this in there, but in this case, I don't necessarily think it's going to be something that's going to come into play with regard to collisions. So I'm going to leave it out of there. Double click on the background. Notice it says that there are 4 fixtures selected for simulation only. Again, the moving fixed jaw and the 2 parallels. The safety plane is also pretty important. The safety plane, this is a global safety plane, and one sets this to kind of establish a height below which one has to start thinking about switching from rapid to controlled feed moves to avoid collisions. So in most cases, a part like this, the top surface of the part plus maybe a 50 thousandths offset upwards would be appropriate. So to do this, I'm going to click on the safety plane, and then I'm going to pick the top of the stock. And notice it places the safety plane right in line with the top of the stock. As I said, I want to shift it upwards a little bit to give me a little bit of clearance. So the way you can do this is by moving the mouse over the safety plane in the display window, right-clicking, and then applying an offset. So we're going to apply an offset of 50 thousandths, and that's going to shift the plane upwards 50 thousandths. So it's hovers slightly above the top of the stock. And again, this is the plane at which you would want to make sure that you control your rapids below this, or be very sure about what you're doing to avoid collisions. So we're almost done with defining the setup. The last thing that I'd like to do is, if you recall, under the machine design, we shifted the home position to this coordinate system here, which is the home position on the Haas machine. The tool change point also should coincide with the machine home. So what we're going to do is we're going to go over to the position tab, and what we're going to do is change these to the offsets, same offsets that we use for the machine home. And I recorded these, so I'm going to just type them in again. So the X offset is 8.844. The Y offset is 4.463. And then the Z offset is 12.608. So as you can see, the tool change point now has moved to the machine home point. And on the Haas machines, that's true. The machine has to go to the home to do a tool change. So having this tool change point makes sense, because when you do your tool paths, you will see after tool changes a motion of the machine from the tool change point to the start of the approach for your operation. So it helps to kind of give you spatially a good sense of where the tool is coming from and where it's going back to at the end of an operation. As far as the rest of this goes, there's nothing else here that's really important at this stage. So again, to summarize, we went through pretty much the important buttons here: the machine definition, the coordinate system, defining the product, selecting the actual geometry for the final part, and the stock, fixtures, and the safety plane, as well as shifting the machine, establishing the coordinate system, the machine home and the tool change point at the actual location of that on the Haas CNC machine.